Can the MySQL database be replicated and synchronized across your laptops and AWS with transaction consistency? Can you do it without moving virtual machines, LXC, LXD, Docker containers? For the past few decades, IT, which evolved from server-centric, low bandwidth, and memory-starved origins, symbolized more infrastructure technologies than information technologies. With the advent of many core servers, ultra high bandwidth networks, and abundant high speed memory, distributed computing is evolving to be dynamic, composed, and collaborative services support on demand. Current ad hoc distributed computing practices fall short in addressing some fundamental and inherent problems with implementing non-functional requirements dealing with availability, performance, security, and compliance, especially to deal with scale and large fluctuations in both workloads and also fluctuations in resource availability. Instead, we have proliferated complexity through point solutions and quick fixes, throwing more and more software at the problem. The meta-knowledge of the intent of the algorithm, the association of specific algorithm execution to a specific device, and the temporal evolution of information processing and exception handling when the computation deviates from its intent, be it because of software behavior or the hardware behavior or their interaction with the environment, is outside the software and hardware design and must be addressed in the distributed systems design. This presentation is aimed at showing you an alternative approach using meta containers and managed services based on a new theory of cognitive distributed computing. With the implementation of the cognitive distributed computing model, it is possible to provide database replication and synchronization with transaction consistency on physical or virtual servers in data centers and private and public clouds. Distributed database cluster management with global visibility and control is also possible. That allows us to provide database high availability and disaster recovery independent of distributed infrastructure management systems. Highly reliable, available, and secure database clusters on even not so reliable distributed infrastructure can be implemented. In this scenario, we will use a 3-laptop cluster with many core processors and one AWS cluster with a virtual machine. We will use a Apache web page acting as a presentation layer, a Tomcat web application acting as a business layer, and a MySQL database representing the data layer. First, we will upload the database in one of the laptops. We will replicate it to AWS cluster, and then we replicate it again back to another laptop. This picture shows the screenshot of 3 multi-core laptops and a virtual machine in Amazon Cloud that we will use to demonstrate the replication, synchronization, and cluster management of the MySQL database. The important point here is to remember that the meta container containing the workflow manager knows the available resources and deploys it on PL001 based on policies, and it also knows that other resources such as PL005, PL002, and PL003 are available for additional resources if required in order to replicate, synchronize, and manage the cluster. This transaction shows the transaction writer using Tomcat can be programmed to adjust the number of records written per minute. So here you can see it is writing 2 transactions per minute, and we will set the transactions to 60 transactions per minute before we attempt to auto-scale MySQL database to Amazon Web Services virtual machine. This screen shows us how to tell the workflow manager to auto-scale with a single click. We also could have defined a policy that says auto-scale the MySQL database when the number of transactions exceeds a certain rate, and share the transaction load across the 2 databases. Notice that the MySQL database has been auto-scaled into the AWS virtual machine, and the number of transactions are continuously being written. After the database is auto-scaled, the 2 databases are synchronized. In the next 2 screenshots, we query the 2 MySQL databases hosted in 2 different places and show that the transactions on both databases are identical. Only the IP addresses are changed in these screenshots. Now we tell the workflow manager to auto-scale the database in AWS to another physical laptop as shown in the next screen. As you will see in the next 3 screens, the auto-scaling is completed, and then the 3 databases are synchronized, and we see that in these 3 screenshots, the database query from all these 3 MySQL databases on different servers are identical, except for the IP addresses shown on top of the screen. During this process, the workflow managers keep track of both the used resources and the available resources, and manage the overall dynamics of the intent of the workflow according to the policies prescribed. We believe that the meta containers and the managed services infuse cognition into both the elementary unit and the whole composed of the elementary units. This is very similar to the observation made by von Neumann in his Hickson Symposium in 1948. The organisms can be viewed as made up of parts which to a certain extent are independent elementary units. We may therefore to this extent view as the first part of the problem the structure and functioning of such elementary units individually. The second part of the problem consists of understanding how these elements are organized into a whole, and how the functioning of the whole is expressed in terms of these elements. Just to conclude, cognition is the ability to process information, apply knowledge, and change the circumstance. Cognition is associated with the intent and its accomplishment through various processes that configure, monitor, and control a system and its environment. Cognition is associated with a sense of self, the observer, and the systems with which it interacts, the environment or the observed. Cognition extensively uses time and history in executing and regulating tasks that constitute a cognitive process. We believe we infuse cognition with this new computing model into Turing machines, and therefore we are able to configure, monitor, and control not only the individual components, but also the groups that create the workflows with the intent of the service as a whole.